Mass percent is the percentage of a particular element within a compound. Because it's mass percent, the units are mass units, which are grams. So the simplest form of the equation is grams of element divided by grams of compound times 100 to give percent. The calculation involves the total contribution of the element of interest, where the grams come from molar masses. We calculate this contribution as number of atoms times molar mass, then divide by the molar mass of the compound and times 100 to give percent. While we include units in almost every other type of calculation we do in a chemistry class, this calculation is one of the few exceptions. You do, however, need to make sure that the result has units of percent and that you have included both the element of interest and the compound in your final answer. So let's work an example. Let's determine the mass percent of each element in sulfuric acid, H2SO4. And we'll start by calculating the molar mass of the compound, H2SO4. The molar masses of the elements are 1.008 for hydrogen, 32.06 for sulfur, and 15.999 for oxygen. The molar mass calculation then is 2 times 1.008 coming from the hydrogen plus 1 times 32.06 coming from the sulfur plus 4 times 15.999 coming from the oxygen. This gives 98.07 grams per mole for the molar mass of H2SO4. Notice that sulfur only has 2 decimal places, which is the fewest number of all of the molar masses that are here, so our final result is rounded to 2 decimal places. Next, we set up the contribution from hydrogen divided by this molar mass. Notice how the part we need, the number of atoms of element times the molar mass of the element, for hydrogen is already here. It's actually already part of our molar mass calculation. And this part right here is what becomes the numerator for the hydrogen calculation. The next part becomes the contribution for sulfur, and the last part becomes the contribution for oxygen. It's the same information we need to calculate mass percent, which makes sense because we're trying to figure out how much does each element contribute to the compound in terms of mass. So for hydrogen, we have 2 times 1.008 divided by the molar mass of the compound, which is 98.07, times 100, and that will give us the mass percent. We have 4 sig figs in the molar mass of the compound, and we have 4 sig figs in the molar mass for hydrogen. The 2 and the 100 are exact, so they will not factor into our sig figs. When we do the calculation, our answer needs to be rounded to 4 sig figs. And when we do the math, we end up with 2.056% hydrogen in H2SO4. For sulfur, we have 1 times 32.06 divided by 98.07 times 100. In this case, we still have 4 sig figs for our compound. We have 4 sig figs for the element, once again, so our final result will be rounded to 4 sig figs. And when we do the math, we end up with 32.69% sulfur in H2SO4. And finally, for oxygen, we have 4 times 15.999 divided by 98.07 times 100, and that will give us percent oxygen. When we look at the sig figs here, we still have 4 sig figs for our compound, but now we have 5 sig figs for the element. Still though, we follow the rules of multiplication and division, and our final answer will have the fewest number of sig figs, which will still be 4. And when we do this math, we end up with 65.26% oxygen in H2SO4.